Okay, we've seen that for a planet moving in the vicinity of the Sun, within the gravitational field of the Sun, that the net force is the mass times the second derivative of the position function. By Newton's law of universal gravitation, this force has magnitude big G, big M, little m over r squared, where little m is the mass of the Earth. Okay, so that's here, or the mass of the planet. If we think of the planet as the Earth, that's okay. But m is the mass of whatever planet we're looking at. And that's the magnitude. The vector is directed radially back toward the Sun, so it's going to be the magnitude multiplied by the negative of the UR vector. And that's going to be our acceleration, our net force, which is our mass times our acceleration, resulting in an acceleration vector, r double prime of t, which we can denote by little a. If we divide the m out here, we get the expression for r double prime of t, which is negative g m over r squared times the UR vector. Now we've already got an expression for the derivative of r with respect to t. We've derived that expression previously, and we write that out, and we note then that r prime of t is little r prime of t times ur plus r of t times d theta dt u theta. And our strategy is going to be find an expression for r double prime, set that equal to negative g m over r squared multiplied by u sub r. So the first step is going to be express r double prime of t as r prime of t prime, which is going to be, now I'm going to suppress the t notation, the function notation. When I write little r, I just mean the function little r of t times ur plus r times d theta dt times the u theta vector prime. Now this is a fairly straightforward expression. We're just going to apply the product rule and the chain rule, and we see that this is going to equal, well, the derivative of this term. Let's just do the derivative of this term. That's going to be r prime prime times ur plus r prime times u sub r prime. Now, switching color, let's write out the derivative of this term. So that's going to be what? Let's regard this term as r times d theta dt u sub theta, product of two functions, the second of which is this part of the function. So chain rule applied in a straightforward manner, not the chain rule, the product rule, gives us the expression shouldn't have had a parenthesis there, but let's go ahead and just put another one in. Okay, so we have the derivative of the r function times the rest of the function plus the r function times the derivative of the rest of the function. Now we're going to have to simplify this. This is going to involve a product rule. And just looking at this, we see that d theta dt times u sub theta prime equals what? It equals d theta dt prime times u sub theta, and use a vector, plus d theta dt times u sub theta prime. Now we're going to be able to write out these derivatives because we know the derivative of u sub theta, and the derivative of d theta dt with respect to t is just the second derivative of theta with respect to t. So let's write that out and back substitute it here and see what we have.